Okay, we are going to solve this harder circuit. I think we're going to get a system of 5 equations and 5 unknowns here. And I'm going to try to color code this as we go. Okay, so we've got 2 different batteries here. Remember, it never matters if you end up putting your currents going the wrong direction. Like if you end up with a negative current at the end, that means you got one of your currents, that current, the one that's negative, pointing in the wrong direction in your picture. And you go, oh, I guess I had that backwards. And you move on with your life. You just make it positive. In order to try to avoid that, anytime we've got 2 batteries, we always probably want to assume that the bigger battery is going to win, that current's going to flow out of the bigger battery, and we're probably charging the other battery. So when I get a current coming down here, it's probably going to flow back into this battery, but we'll see. Maybe I've got that wrong and I'll get the sign of this current wrong. It's no big deal. Okay, so I'm going to assume we've got I1 flowing out of the big battery. And that's still I1 here. That's going to split. We've got to use our junction rule here. So I2 and I3 are going to come out of I1. So that's my first equation. I1 will be 2 plus 3. I'm going to thin that down a little bit here. There we go. Okay, so now let's follow these around. Oh, look, 2 is going to split right here into 4 coming down and 5 coming over, because we've got a junction. So 4 is going to flow down here, 5 flows around, those join back up again. This is I2 again, because 4 and 5 came back together there, and then 3 and 2 are joining back together. So we'll have I1 again down here. Okay, so I get a second equation from a junction rule there. I2 will be 4 plus 5. Okay, now I got to draw in my loops. So I've got 5 unknowns. I'm going to need 5 equations. I'm going to need 3 loops. There are a bunch of different loops I could draw. I could draw 1. Here's a second loop. That would be 2. A loop all the way around. That's 3. I could draw a loop in here. That's 4. A loop here. That's 5. A loop here. That's 6. There are 6 different loops I could draw. That would give me a total of 7 equations, or no, let's see, 6 loops, 8 different equations I could write down. I only have 5 unknowns. Some of those will be redundant. I only need to come up with 5 equations total. So I've got 2, I need 3 more. So I'm going to draw loop 1 here in blue. And I got to figure out which direction I want that loop to go in. So let's call that loop 1. And all of my voltage rises around will be positive. All my voltage drops will be negative. Remember, we're looking at which way the loop goes through a battery. Going through a battery, so look at this loop here. It's going from positive to negative. That's a voltage rise. We're going through the battery the correct way, the way the battery wants current to flow through it. That will be a voltage rise of 12 volts. Now, when we're going through resistors, we compare the loop and the current. If the loop and the current both point in the same direction, a resistor is a drop. Batteries want to be rises, resistors want to be drops. If everything is flowing the normal direction, batteries will be rises, resistors will be drops. So I1 here is flowing through this resistor from left to right. So is my loop right there. So this guy will be a drop. And what's that voltage drop? V equals IR. So that will be 2 times I1. That voltage times the current that actually goes through there. Okay, now over on this guy. My loop is going down. My current is going down. So through this resistor, we're going through it the normal way. The loop and the current agree, so this is a drop of minus 3 I3, because that's the current that's going through there. And now I'm going around, I'm just following along this loop here. Again, my loop is going to from right to left, so is this current. Those agree. So this is a voltage drop of minus 1 I3, and that should equal 0. All the rises and drops around a loop equals 0. All right, let's do red, and I don't know, let's maybe do a loop in here. So I don't know. I always draw my loops going around clockwise here. It really doesn't matter. But I try, because I don't want to mess up my signs, I try to, if I can, keep my loops and my currents going in the same direction. Okay, so going around this loop through R4 here, the loop's going down, the current's going down. Let's call this loop 2. That's going to be a drop. So that will be minus 4 I4, V equals IR. Let me draw that 4 a little better. Now, here's where people mess this up. I'm going through this battery backwards, the loop. I don't really care at this moment what the current's doing, even though the current is going backwards here. What I care about is which way is the loop going through this battery. The loop is going backwards from positive to negative. That makes this guy a voltage drop. So that will be minus 10 volts because that's the voltage. There are no resistors here. And then on this loop, my current's going down, my loop is going up. I'm fighting the current here. I'm going backwards through this resistor. He'll be a voltage rise. So plus 3 I3. See right here, my loop is flowing up, but I3 is flowing down. And that's it. Those are all the resistors or batteries on loop 2 there. So that must equal 0. And then we'll color code this. I'm going to do a loop here. Again, I'm going around, was that clockwise there? So that's loop 3. Sometimes you can strategically pick loops. Like if you've got some potential loop that's only got one current on it, then you could just solve for that current. If I had a loop that only had I1 on it anywhere, then I would just solve for I1 and be like 1/5 of the way done. We don't have anything like that here that I could strategically pick some loops. I'm just kind of picking loops at random here. All right, going around this loop. So I'm going to start here. My current's flowing down. My loop at this spot is also going down. If the loop and the current agree, resistors are dropped. So that will be minus 5 because it's a 5 ohm resistor times I5. Okay, my loop is flowing around and going back up through this battery. So I'm going from negative to positive. On this loop, I'm going through the battery correctly. See, this loop went backwards through the loop. This loop goes through the battery the right way. That makes him a voltage rise. So plus 10 volts. And then I go through this resistor. My current's going down. My loop's going up. When the current and the loop oppose each other, you get a voltage rise through that resistor. So plus 4 I4, that's the current that goes through that resistor. Okay, so now I've got 5 equations. So I'm going to solve this system using my calculator, using the matrix functions on the calculator. So my goal is to write this in matrix form. Let me switch to a more pleasing to the eye color here. My goal is to write this as some matrix A times my vector X equals B, and then write this in augmented matrix form. So my vector X here is the vector, that needs to be bigger, I1 through I5. So I want to write this where all of my I's line up, all my I2s line up, and so forth, and all my numbers are on the other side. So I'm going to number these equations using boxes here. So I know I numbered these loops as loops. I'm going to call the equations something different. And I'm going to write them all in the same form. I want them to go I1, I2, I3, I4, I5, and then any numbers left over on the other side. So equation 1 will be I1 minus I2 minus I3 plus 0 I4, 0 I5 equals 0. Equation 2 is 0 I1 plus I2 plus 0 I3 minus 1 I4 minus I5 equals 0. I just moved everybody to the other side. Equation 3. So that I don't have to deal with all these negatives, I'm going to kind of do some of this in my head here. I'm going to move all these negative guys to the other side to make them positive. So then I would get 2I1. I don't have any I2s. In fact, I had 2 different I3s. Because this was a typo here. Right there, oh, I'm glad I caught this. That was a typo right there. And I hope you caught that as I did it. As I go around this loop, that last one was 1 times I1. I probably said it and then wrote it wrong. Oh, that was blue. So I can combine those together right there. See, I've got that I1 and that I1. So I've got minus 3, but when I move it to the other side, plus 3 I1. I don't have any I2s in there, so plus 0 I2. I've got a 3 I3. The other 2 guys are 0. And then that will equal 12. Okay, this equation, what I'm calling equation 4, the red one. Again, I guess I'll just move the 10 to the other side. So I've got no I1. That's a 0. 0 I2s. 3 I3. Negative 4 I4. 0 I5. And that will equal, when I move the 10 to the other side, 10. And then finally, we're about 2/3 done with the problem. Here, equation 5. So I've got no I1, 0 I2, 0 I3, 4i4 minus 5i5. And then when I move that 10 to the other side, that will equal -10. Okay, so now what I'm going to do is extract the matrix out of this by basically factoring out this vector from this side. So my matrix A here, I'm really just writing down all the coefficients. That will be 1, -1, -1, 0, 0, 0, -1, -1. That did not line up right. 0, 1, 0, -1, -1. 3, 0, 3, 0, 0. I'm just following along here. 0, 0, 3, -4, 0. And 0, 0, 0, 4, -5. That's my matrix A. My column vector on the other side is just all these coefficients over here. So that's 0, 0, 12, 10, -10. Now we have the fact that A times my variable vector equals my constant vector. Okay, so you've taken pre-calc, you know how matrices work. Okay, now how are we going to type this into the calculator and have the calculator do all the work for us? We're going to use what's called the augmented matrix. And what we do is we tack this column vector here on the end of this matrix. I'm trying to zoom out so I can see all this. Okay, so we're going to do 1. I'm just recopying the matrix A here. And then I'm going to put in this dashed line. Zero, 0, 3, -4, 0, and 0, 0, 0, 4, -5. Of course, we could solve this entire system just by solving it by hand using a bunch of back substitution, but that takes forever. We've got these fancy calculators. Let's use them. Okay, so I took this matrix, I put in this dashed line, and then I put the constant vector over here on the side. So now that makes this, remember, we always do the rank of a matrix rows by columns. So I've got 5 rows and 6 columns. So this is a 5 by 6 matrix. Okay, now we're going to get our fancy calculator out. Okay, so I'm going to come here into my calculator and I'm going to go into the matrix button. See it right there? It's in blue. So I have to hit second to get to it. Second matrix. And I may already have some matrices in here. I may not. I'm going to use one that doesn't have anything in it. And I'm going to tell it it's a 5 by 6. Oh, I went to the wrong place. Sorry. I want to edit. So I'm going to go into C and edit and tell it it's a 5 by 6. And now I'm just going to type these in. And as I type, the calculator will scroll across a row. So 1. Now, when you're doing negatives, you got to be careful here. This is the negative button on your calculator. If you use that button, the minus button, it'll get mad at you and it won't work. So I want -1. 0, 0, 0. Now, watch what happens here. When I hit this last 0, that one right there, it's going to scroll to the next column. I did not type that right. -1, here we go. Okay, 1, -1, -1, 0, 0, 0, and then it pops down to the next row. 0, 1, I'm just reading across this row. 0, -1, I have to hit the negative button. -1, 0. 3, 0, 3, 0, 0, 12, 0, 0, 3, -4. I know you got to watch me type all these in. 0, 10. Oh, this one was 0. This one was 10. We got 3 zeros, 4, -5, and -10. Now you've watched me goof a couple of times here. So once I get this all done, first thing I want to do is get out of this menu. So I'm always going to go second quit, get out of there so I don't mess it up. And then I come back in here. I go second matrix, go down to that one I picked and hit enter a couple of times, make it display it so I can compare. Because you watch me mess up like 4 times there. So I like to go through and make sure I actually put everything in correctly. Okay, I did. Now I'm going to have it solve this system of equations. So I'm going to come back into my matrix menu, second matrix, and I'm going to go over to math and all the way down to RREF, row reduced echelon form. I'm going to hit enter. Now it's asking me what matrix do I want to do this on. Now, I've seen people make this mistake. You might think, oh, I can just do alpha C. No, it won't interpret that as the matrix. See how the matrix has matrix bars around it? That will confuse it. It won't work. I have to come into my menu, so second matrix, and pick the one I want, C. And then actually it'll work if you don't close that parenthesis, but I like to, and hit enter. And right here, we should end up with the identity matrix. If you don't get the identity matrix, all zeros except 1 on the main diagonal, you've done goof somewhere. If you do, if you get all 1s there, then these are your currents, I1 through I5. Notice we got I4 backwards. It's a negative. What does that mean? That means that I was wrong. This current actually flows up instead of down. I don't care. If you get a negative on one of these, it doesn't matter. You don't have to change anything. You don't have to redo the problem. In fact, you just ignore the negative. You make a mental note of it and go, oh, I guess it went the other way. So we're not actually charging these batteries. These batteries are working together. The current is going to flow the right way through that battery. Okay, I made a mental note of it. When I write all my answers, I don't even bother writing the negative. All right, let's write down everything we got. Okay, I am going to do this on a separate screen because it won't let me. It's not cooperating with me today. It won't let me display as I'm writing. So I got these numbers. I'm going to go to 2 places. Notice when I get to I4 here, I'm not even going to bother writing that negative. Notice I put amps on all these. Now, what I might want to do next is now find out the voltage drop again across each of these resistors. How do I do that? V equals IR. Then I might want to find the power dissipated through each resistor. How do I do that? P equals IV. So after this, I'm going to use V equals IR, and power equals I times V to find the voltage drop across each resistor and find the power dissipated by each resistor. So all you got to do is match up, oh, well, which current went through this resistor? Which I am I using on each R? And of course, these are all in volts, and these are all in watts. Okay, so there's a good place for you to stop this video. You don't have to watch the rest. I'm going to use the second method now, like you may be interested in this, to see if I got all this right. See if I got to re-record this video. So I am going to use an online systems of equation solver to solve this a different way instead of using the calculator. Now, I don't want to have to type in all these subscripts. So I'm just going to call these A, B, C, D, and E instead of I1, I2, and so forth. And I'm going to, I wonder if I can get both of these on the screen at once. Hold on, let me pause. Okay, so there are plenty of online systems of equation solvers. Like Wolfram Alpha is one of mine favorites. See that there will only do 4. Here, you got to learn how to use these to type into some of these. I'm just kind of showing you. Here, I can just type in all the matrices or the matrix elements and so forth, or I can just use plain old Wolfram Alpha. Again, I'm going to make my life simpler, call these A, B, C, D, and E. So I have A equals B plus C, comma. Let's see, that'll be B equals D plus E. I think it'll let me get by with using lowercase e there. It might interpret that as the natural number E, but I don't think so. I think we'll be okay. I might have to change that to a capital E. All right, so then we'll have 12 minus 2A minus 3C minus another A. I might as well just call that minus 3A there, right? Equals 0. What do we got here? Negative 4D minus 10 plus 3C equals 0. And then this one here, negative 5E plus 10, plus 4D equals 0. So I should have 5 equations. All right, let's see if I typed all that right. Quickest way to check that, see if we get the same answers. I did not get the same answers. All right, so let's see if I typed one of these wrong. I'm going to pause and check that. I'm not going to make you watch. Yeah, right here. That should have been 12 minus 2A. All right, let's see if that fixes it. I can do approximate form here. That did not fix it. Let me check again. Okay, and that fixed it. That should have been a 3 right there because we had minus 2, minus 1, not a 2 there, a 3. So I typed all these in. It tells me, like I had to hit the little button here to see approximate form. These were all fractions to begin with. But look, same numbers we got. So either way, you can do this on any of your assignments. You just got to tell me which way you're doing it. I don't need to see all the work. If you're using a matrix, like this is the stuff you would do here. Like I just have to see this. If you get to this point where you get your 5 equations and you're using some systems of equation software, then you would just say, I solved the system using Wolfram Alpha. So the work I have to see is getting to here, drawing the loops, writing out the equations, and then just tell me how you solved it after that. Okay, so I think we got this one right.